Hello, and thank you for joining us today. We're excited to talk about how organizations can unlock the full value of large language models by leveraging human expertise.
That's right. At Appen, we specialize in creating high-quality data sets to train and optimize AI models. We work closely with many foundation model builders, helping them fine-tune and evaluate their models with precision.
One of the benefits of collaborating with multiple foundation model builders is that it gives us a unique perspective on the leading techniques for optimizing these models. We've seen firsthand what works and what doesn't.
Exactly, and today we're here to share some of those insights. We'll explore the best approaches to creating accurate and safe LLM solutions that truly deliver value. Let's get started.
Before we dive deeper, let's outline what we'll cover today. We've structured our discussion into four main sections.
First, we'll start by sharing some recent research we conducted on generative AI model development. It offers a fresh perspective on the trends shaping this space.
Then, we'll move on to some of the challenges in implementing retrieval-augmented generation, or RAG, and highlight how leveraging human expertise can significantly improve performance.
In the third section, we'll share a case study from one of our recent projects, which focuses on improving model safety, a critical aspect for deploying reliable AI solutions.
And finally, we'll wrap up with key takeaways, including our thoughts on the value of combining human data preparation with automated approaches for building more effective AI solutions. Let's begin with some recent research that Appen has recently published. This research provides fresh insights into generative AI model development, shedding light on the evolving landscape of AI and the role of human expertise in shaping these advancements. We recently conducted a survey with technology decision makers to get a better understanding of the trends in training and evaluating AI models.
And the results were pretty interesting, right? On one hand, we saw a 17% increase in the adoption of generative AI in 2024. That's not too surprising, though, given how everyone's racing to extract value from large language models.
Exactly. The primary use cases driving this adoption seem to be centered around improving productivity and efficiency in internal business operations, which makes a lot of sense.
But here's where it gets interesting. The percentage of AI projects actually reaching deployment has dropped by over 8% since we first started tracking this back in 2021.
Right. And that decline seems to mirror the rise in experimentation across the industry. It's a reflection of what's happening in the market, but it raises an important question.
Why are so many projects struggling to make it beyond the proof of concept stage? It's a critical issue, and understanding the reasons behind it is key to figuring out how to close that gap effectively.
To figure out why so many AI projects aren't making it to deployment, we asked about bottlenecks in the process and compared the results to last year. The findings were pretty revealing.
They really were. The biggest bottleneck we identified was data management, specifically preparing the data needed to optimize LLM models. It's a complex and resource-intensive process.
And along the same lines, we also saw that a lack of sufficient data is becoming an even bigger challenge for organizations. It's a growing issue as models get more advanced.
What's interesting, though, is how things have shifted. Last year, the biggest bottleneck was a lack of technical resources, but this year that's decreased significantly.
Right, and it makes sense. Teams are becoming more familiar with working on LLMs, and there are more tools and resources available to support them now.
Absolutely. This shift really underscores how generative AI development is evolving, but it also highlights the importance of addressing data-related issues. Without tackling those bottlenecks, it's tough to unlock the full potential of these models.
The data bottlenecks we're seeing seem to stem from the fact that customizing LLMs requires a completely different approach compared to traditional AI model development.
Absolutely. When you look at the three broad categories of AI models, the data needs are really distinct. Take traditional AI and ML models, for example, those used for things like prediction or recommendation.
Right. Those models typically rely on structured data, which is relatively straightforward. Think labeled datasets, like images tagged with specific attributes. It's more simplistic in nature.
But then you move to large language models, and the picture changes completely. These models need large-scale data ingestion, and the data sets have to be extremely diverse and unstructured. Quality and accuracy are absolutely critical to ensure robust performance.
And when we're talking about customized LLMs, ones trained on a company's internal knowledge base, the data challenge becomes even more complex. Often, you're dealing with unstructured documents like PDFs that include a mix of charts, diagrams, and other content. Labeling this kind of data requires a deep understanding of context.
Exactly. This shift toward broader, knowledge-intensive AI applications demands a fundamentally different approach to data. Enterprises need to manage greater volumes, pull from more diverse sources, and handle increasingly complex data preparation.
To effectively customize an LLM, it's essential to combine structured data preparation with unstructured data enrichment pipelines. That's the only way to ensure the data meets the quality standards necessary for success. Let's shift gears now and talk about how Appen has been helping organizations tackle some of the major data challenges in LLM model customization. Let's talk about some of the common challenges our customers face when customizing LLMs, particularly when using retrieval-augmented generation, or RAG.
One of the biggest pain points is data preparation. Customization requires meticulous attention to detail in this area. While many enterprises are very experienced with structured, tabular data, working with unstructured data at scale is a whole new challenge, and a much more complex one at that.
Exactly. The second major challenge is measuring performance. Standard benchmarks that work for general-purpose LLMs often don't translate to enterprise-specific use cases. What these organizations really need is a customized and robust methodology that accurately reflects their unique requirements.
And the third pain point? Managing system complexity. It's often difficult to trace insights back to the root cause of a problem, and more often than not, the issue stems from the data preparation stage.
These challenges aren't just tough to solve, they're even harder to automate. From what we've observed, systematic human involvement is essential to addressing each of these issues.
Absolutely. It's this kind of targeted human expertise that ensures models are accurate, effective, and aligned with an enterprise's specific goals.
Let's talk about how we've been helping our customers improve their RAG systems by incorporating human oversight.
Definitely. Over the past 18 months, we've partnered with a wide range of companies to identify where human oversight can make the biggest impact during the different steps of RAG deployment.
And through those partnerships, we've pinpointed 13 common challenges that most RAG systems face. Today, we'll focus on 4 of them.
Don't worry, though. We're not leaving you in the dark about the rest. We've put together a RAG ebook that walks you through all 13 challenges in detail.
That's right. And if you want to dive deeper, we've included a link to the ebook in the video description. Make sure to check it out when you have the time. Before we dive deeper into the challenges, I think it's important to introduce Appen's AI data platform.
Good idea. This platform is central to everything we do, especially for our large-scale data efforts with model builders and leading AI companies.
It's also the foundation of how we optimize enterprise large language model customization. The platform is designed to handle highly complex data workflows.
Exactly. It supports both human and automated data enrichment techniques, making it incredibly versatile and powerful.
In fact, it's the backbone of all the work we do. Everything we'll discuss today is built on this platform's capabilities. Let's start by walking through some of the challenges involved in building effective RAG systems. The first challenge we see is the absence of contextual metadata.
Right. At its core, a good RAG system relies on well-prepared data, and contextual metadata is a big part of that. One common issue occurs during the chunking process, where text is broken down into smaller pieces for retrieval.
Exactly. Without proper context, chunks can end up including irrelevant information, which adds noise. Another issue is randomly defined chunk boundaries. They can lead to inaccuracies when selecting the right information.
And there's also the problem of chunk size. Chunks that are too large may include unnecessary details, while chunks that are too small can miss important context needed for retrieval.
There are some great tools out there to automate chunking, but errors still happen. That's where our platform comes in. It includes built-in human review workflows, allowing for refinement and adjustment of chunked text based on its context.
This approach ensures contextual integrity and helps improve the accuracy of model responses. It's a key step in overcoming this foundational challenge.
Let's move on to the second challenge: Prompt quality issues for evaluation.
Right. Understanding performance is critical for any AI model, but performance gaps can often go unnoticed if you don't have a strong set of prompts for evaluation.
That's why building a set of golden prompts is considered a best practice. These are carefully curated prompts that you can use consistently throughout your testing and evaluation process.
Exactly. Using golden prompts helps maintain the quality of your RAG system over time, but the real challenge is creating the right set of prompts. They need to cover a wide range of behaviors and topics to ensure comprehensive evaluation.
That's where our platform comes into play. It supports the review of existing customer prompts and helps create new ones to refine and expand customized golden prompt datasets.
This ensures you're getting the most accurate evaluation results possible, which is essential as you continue to build and optimize your models.
Now, let's discuss the third challenge: the effectiveness of re-ranking.
This is a big one. Re-ranking mechanisms often struggle to present the most relevant data chunks first, which can significantly impact the overall performance of the system.
That's where human expertise makes a difference. Human reviewers can assess the quality of model responses across dimensions like relevance, accuracy, and level of detail, or even apply custom criteria tailored to specific needs.
Exactly. By reviewing and ranking chunks of information based on their relevance to a given prompt, humans can help train the model to prioritize the most relevant data. This creates better alignment with end-user needs and expectations.
And it doesn't stop there. This process can also be used to rank and compare different models or conduct A/B testing, providing valuable signals that drive model optimization.
It's all about leveraging human input to refine the re-ranking process and ensure the best results for both the system and its users.
The fourth and final challenge I'd like to discuss is model safety.
That's such a critical topic. Model safety is a key concern when it comes to deploying generative AI solutions, especially given the risks involved.
Absolutely. AI models often reflect or amplify the behaviors present in their training data, which is why unintended bias, erroneous information, or even hallucinations in LLMs are so common.
And researchers are still uncovering more complex vulnerabilities in LLMs. The stakes are only getting higher as enterprises integrate generative AI deeper into their operations. That's where human contributors come in. They can conduct what's known as LLM red teaming, posing challenging, off-topic, or even adversarial questions to test the RAG model.
By analyzing the responses, you can pinpoint potential weaknesses or biases and take proactive steps to mitigate them. It's an effective way to ensure the model's safety before deployment.
Exactly. To illustrate this process, let's walk through a case study on LLM red teaming in more detail.
Let's take a look at a red teaming case study. Red teaming is a proactive approach to understanding LLM safety by identifying potential harms and risks before they become real-world problems.
The goal here is to establish a systematic, repeatable methodology that extracts valuable insights to improve the safety and reliability of LLMs over time.
Exactly. The methodology we use involves four key steps. First, we define the objectives and scope of the testing. This includes selecting from a robust set of options, like testing for specific harm types, such as violence, sexual content, or illegal activities, or attack strategies, like virtualization and prompt injection.
The second step is planning the approach. This involves determining how the platform will interact with the AI chat feedback function, ensuring the testing is thorough and targeted.
Then comes step 3: managing the red teaming data collection. This requires close collaboration with the human contributors who create the prompts and perform the evaluations.
And finally, step 4 is reporting. We analyze the prompts, responses, and evaluations from the red teaming process and use these insights to create the data needed to optimize the model. It's a comprehensive process designed to identify vulnerabilities and make meaningful improvements to ensure model safety.
Let's walk through a real-world example of how we use a crowd workforce to evaluate model safety through red teaming.
Great. So, what's the first step in the process?
It starts with setting up the user prompts. This involves open-ended testing using a variety of prompts, including adversarial prompting techniques. We rely on a highly experienced crowd workforce that gets very creative with their approaches. They use different frameworks to maximize the coverage of prompt types, ensuring a comprehensive evaluation.
That's key. You need diverse and challenging prompts to really stress test the model. What happens next?
The next step is connecting with the application. In this case, it was built on a foundation model and linked to a RAG knowledge base. The goal was to assess the level of harm associated with the outputs. The model was evaluated across multiple dimensions: toxicity, misinformation, and personally identifiable information leakage.
And once the outputs are generated, the final step is evaluating the model's responses, right?
Exactly. We carefully assess how the model responded to each prompt, whether or not the initial prompt was flagged as harmful. This step is crucial for identifying any vulnerabilities or weaknesses in the model's behavior.
It sounds like a thorough process that provides valuable insights for improving model safety.
Absolutely. It's all about proactively identifying risks and taking action to mitigate them before deployment. Let me show you a simple example of the interface we use for a generalized red teaming job.
Sounds great. What's the structure of the job?
It follows a three-step approach. The first step is intent. Here, the user selects the objective of their test scenario. This could be choosing a specific prompting technique or targeting a particular area of attack.
That makes sense. And the next step?
The second step is prompt creation. This is where the user creates the actual prompt that will be used to test the model.
And I assume the third step is where the interaction with the model happens?
Exactly. The third step is the live chat test. This generates real-time feedback from the model, which the user can then evaluate for potential harm. The evaluations can include selecting from predefined categories, providing free text input, or suggesting appropriate rewrites.
That's a very hands-on and interactive approach. It seems like it would provide detailed insights into how the model handles different scenarios.
It absolutely does. This interface is designed to make the red teaming process intuitive while delivering robust evaluations. One thing we've noticed is that adversarial prompts can be surprisingly effective during testing. In our projects, we often see success rates for certain models and categories reach as high as 40 to 50%.
That's a significant success rate. Did you observe similar patterns in the project you mentioned earlier?
Yes, but with some interesting variations. When we focused on eliciting harmful outputs from the models, success rates ranged from 5% to as high as 60%, depending on the model and category. The performance differences between the models were pretty striking.
Can you give an example of how the models varied?
Sure, Model 1 answered almost every prompt, but most of its responses were harmless. In contrast, Model 3 declined to answer nearly a third of the prompts outright.
And what about Model 2? Where did it land?
Model 2 was unique. It answered everything but, unfortunately, produced somewhat harmful responses in about 80% of instances. That highlighted some major vulnerabilities.
I can see how this would be incredibly useful for benchmarking. It gives the customer a clear view of how different models perform under stress.
Exactly. It's not just about identifying issues, but also providing actionable insights that can guide improvements. Another fascinating part of this study was analyzing the model's ability to differentiate between in-scope and out-of-scope prompts.
That's such a critical area, especially for enterprise applications. Ensuring the model doesn't answer questions it wasn't designed for, like complex queries in legal or finance domains, can help prevent risky behaviors, such as offering persuasive or advisory responses.
Exactly. In this study, the guardrails performed noticeably better in the legal domain than in the finance domain. In legal, the model had reasonable rates of accurate detection and managed to block a fair number of out-of-scope prompts.
But it struggled more with finance, right? I think you mentioned it had issues distinguishing in-scope from out-of-scope prompts in that area.
That's correct. For finance, the model barely blocked any of the out-of-scope prompts, which highlighted a significant gap in its guardrail capabilities.
That's an intriguing result. I imagine it also raised some questions for the research teams.
It did. The insights weren't always easy to explain, but they were incredibly valuable for directing targeted efforts to refine out-of-scope guidelines and address those specific vulnerabilities.
It's a great example of how these analyses not only surface problems, but also inform the next steps for improving model safety and reliability.
We have been fortunate to drive favorable results for our customers across a wide range of LLM red teaming projects. We've handled general, open-ended red teaming projects, where we test models broadly to uncover vulnerabilities and potential harms.
And I imagine there's a lot of demand for customized evaluations too, right?
Absolutely. We've conducted custom evaluations tailored to client-specific harm taxonomies and test criteria. These are highly targeted efforts designed to address unique enterprise needs.
What about evaluating the outputs? That's a critical aspect of ensuring model safety and alignment.
Definitely. We've worked extensively on the evaluation and annotation of generated content, ensuring it meets the desired standards for relevance, accuracy, and safety.
And with multimodal LLMs becoming more prevalent, I assume red teaming has expanded to cover those as well?
Exactly. Multimodal LLM red teaming is another area where we've delivered impactful results, addressing the added complexity of systems that handle both text and visual inputs. It's all about meeting the unique challenges of each project with a flexible and effective approach. Let's now wrap up with a few closing points. One thing we consistently see across our customers is that human annotation remains the gold standard or the ground truth for data.
That's true. The level of customization, data diversity, and domain-specific knowledge that humans bring is still unmatched by AI models today. But scaling that expertise efficiently and cost-effectively is a big challenge.
Exactly. That's where Appen's unique human AI co-annotation approach comes in. It's designed to blend human expertise with AI efficiency for better results.
Can you explain how it works?
Of course, the first step is generating pre-annotations. For example, providing an initial model response to a prompt for contributors to refine. Then, we assess the quality of contributor responses by comparing the model's annotations with human annotations.
That's a smart way to ensure quality. What about handling specialized data or sensitive content?
For that, we classify data for smart job allocation. This includes routing data that requires domain expertise or flagging potentially harmful content for specific handling.
And how has this approach performed so far?
We've seen very promising results. Not only have we achieved over 50% efficiency gains on tasks, but we've also improved data quality by 3 to 4%. It's a win for both productivity and accuracy.
That's impressive. It really supports the idea that the future of data preparation is a mix of human expertise and AI.
Absolutely. We strongly believe that combining human and AI capabilities is the key to solving complex data challenges at scale. Let's wrap up with a few key takeaways from today's discussion.
Sure. First, while there's a lot of effort and investment going into AI, we're still seeing that many experimental projects are struggling to make it into production.
That's where human oversight comes in. It's critical at every stage of a RAG system to ensure the creation and maintenance of high-quality data.
And we can't overstate the importance of red teaming. It's a vital step in developing safe models, and humans will continue to play an essential role in that process.
Finally, there's the challenge of managing data workflows. It's a complex task, and having a robust platform to support the creation and management of high-quality data assets is a foundational requirement for successful model development.
Agreed. Addressing these challenges head-on is what will allow organizations to unlock the true potential of AI while maintaining safety and reliability.
That brings us to the end of our discussion. Thanks so much for your time today.
If you'd like to dive deeper into what we've covered, I highly recommend checking out our RAG ebook. It's packed with valuable insights and best practices for RAG development.
You can find the ebook on our website at appen.com, and we've also provided the link below for easy access.
Thanks again for listening, and we look forward to seeing how you apply these strategies in your own AI initiatives.